The objective of this lesson is to compare ratios using tables. In previous lessons, students generated equivalent ratios for a given pattern using tape diagrams, bar models, and tables. Today, students will generate and compare two sets of equivalent data using two colored counters and tables. Let's begin with our first problem. Camilla makes a lemonade drink by mixing 1 can of concentrate with 3 cans of water. Hudson makes a lemonade drink by mixing 3 cans of concentrate with 5 cans of water. Compare the two drinks. Do both recipes taste the same, or does one have a stronger lemon flavor than the other? One way to compare the two drinks is to look at the equivalent ratios of the recipe using two colored counters and tables. Let's model the ratios using two colored counters, and let's record the results in a table like this one. The yellow side of the counter will represent the cans of lemonade concentrate, and the red will represent the cans of water. Camilla has 1 can of concentrate for 3 cans of water. Lay out 1 yellow counter followed by 3 red counters, and then let's record this in the table. Hudson has 3 cans of concentrate for 5 cans of water. Lay out 3 yellow counters followed by 5 red counters, and then record this in the table. Now let's double the recipe for both. Doubling the recipe is the same as multiplying the initial recipe amounts by 2. Camilla's doubled recipe will be 2 cans of concentrate, which is represented by 2 yellow counters, and 6 cans of water, which is represented by 6 red counters. Hudson's recipe doubled will be 6 cans of concentrate and 10 cans of water. This will be represented by laying out 6 yellow counters and 10 red counters. To represent and manipulate counters for all of the recipes would take a lot of counters. A more efficient way to calculate the amount of concentrate and water would be to multiply the initial amount by 3, 4, 5, and so on to get the next set of ratios. Let's start with Camilla's table. The next ratios to record will be the initial amount tripled or multiplied by 3. The concentrate will be 3 cans because 3 times the initial amount of 1 can is 3. The water will be 9 cans because 3 times the initial amount of 3 water cans is 9. Hudson's recipe tripled would be 3 times the initial 3 cans of concentrate is 9 cans. The water would be 3 times the initial 5 cans of water is 15 cans. Continue the ratios for the recipe quadrupled and quintupled. All the entries in Camilla's table will have the same flavor, and all the entries in Hudson's table will have the same flavor, because they are multiple batches of the same recipe. Is there a point in the table where both Hudson and Camilla have the same amount of concentrate? Yes, at 3 cans of concentrate. For 3 cans of concentrate, Camilla has 9 cans of water, and Hudson only has 5 cans of water. Camilla's recipe has more water than Hudson's. Therefore, Hudson's recipe will have a stronger lemon flavor because he has less water than Camilla. Another way to compare the two recipes is to find a unit rate or value of a ratio. Let's start with Camilla's. For every 3 cans of water, there is 1 can of concentrate. So for 1 can of water, how much concentrate would there be? In order to share the 1 can of concentrate equally with the 3 cans of water, the 1 can of concentrate must be divided into thirds, and one of the thirds will be shared with each can of water. Camilla's recipe has 1/3 can concentrate for every 1 can of water. Let's look at Hudson's. For every 5 cans of water, there will be 3 cans of concentrate. In order to share the 3 cans of concentrate equally with the 5 cans of water, the concentrate must be divided into fifths. Share one of the fifths with each can of water by labeling it with a 1, 2, 3, 4, or 5. Each set of numbers will go with that can. For example, all parts of the concentrate labeled 1 will go in water can 1. There are 3 parts of concentrate that go with each 1 can of water. Hudson's recipe has 3/5 can of concentrate for every 1 can of water. Finally, compare the unit ratios. Camilla's 1/3 concentrate is a smaller amount than Hudson's 3/5 amount of concentrate per can of water. Hudson's will have a stronger lemon flavor. The objective for this lesson was to compare ratios using tables. We met this objective by modeling the ratio using two colored counters and generating equivalent ratios in a table to compare amounts in a recipe. We compared amounts of lemon in a recipe using equivalent ratios as well as using a unit rate for each ratio.